but I'm going to make sure we cover at least one or two of each type. So we're now going to look at 1.5. Yep, let's see it up there. So 1.5, and I'm going to pick these from our textbook. And there's many different types of these. There's geometric problems. There's consecutive integer problems. There's right triangle problems. And then also some other types that work with gravity. So I'm going to be picking these from our textbook. And each one of these is going to be a little bit different. These are going to require us to use, in many cases, zero factor or the square root property to solve them. And we're going to start off by talking about consecutive integers. So we're going to begin by looking at consecutive integers. And what are consecutive integers? Well, they're going to be back-to-back numbers. So consecutive integers would be things like 98, 99, 100, 101, and so on. Okay, so consecutive integers are back-to-back numbers. Now, when we talk about consecutive integers, we need to make sure we understand whether they are consecutive integers or even or odd. And if it just says consecutive integers, these have a gap of 1. And so when we work with these consecutive integers, the first number, we're going to call it x. The second number is going to be x plus 1. And the third number would be x plus 2. So each time when we work with consecutive integers, we add 1. If they are even or odd consecutive integers, we add 2. Do I need to move the TV back a bit? I can if I need to. Is it okay? Can everyone see it, hopefully? Okay, yep. If I need to, I can move it back. I know it's hard to get it to where everyone can see it. But when we talk about consecutive even or odd integers, these are going to be things like 2, 4, 6, 8, 10, 12, and so on. Or they can be things like 3, 5, 7, 9, 11, 13. These have a gap of 2. So that means when we work with consecutive even or odd integers, the first number is x. The second number is not x plus 1, it's x plus 2. And the third number, we add 2 again, so that would be x plus 4. So these are actually very, very simple to set up. There's not much to these. We have to, though, make sure if it's a consecutive integer or if it's even or odd. If it's just a consecutive integer, we add 1. If it's even or odd, we add 2 every time. But these are much easier than the investment and the mixture questions that we did in 1-2. So these questions are going to be much easier. Now, when we work these out, we may get multiple solutions. We may not just have one, we may have 2 solutions that work. So we're going to begin on page 147 with question 13. And these, again, are the ones that students do the best with. They're very easy to set up. There's not a lot to them. It's just that when we get our answers, we need to make sure that we solve it and get all the solutions. Because on these, we may get multiple answers. So question 13. Find 2 consecutive odd integers whose product is 63. So first off, how many integers do we need? We need 2, and these are even. or odd. Which one are they? Let's see. We're looking at 13 here. These are odd. So if they're odd, then that means the first number is going to be x. The second number is x plus 2. Now, what are we looking for? Well, we are looking for the product. And when we talk about product, that means we multiply. So the first number times the second number now is going to give you that 63. And that's the setup. So there's not much to these once we have it set up. So now we can go ahead and we can finish this. So now we'll go ahead and plug in our variables. And so if I plug in my variables, the first one is x. The second one is x plus 2. And that equals now 63. These require a bit to actually finish because we're going to have to now use the zero factor. And before we can do that, the first thing we do is we set it to 0 and we clear out our parentheses. So distribute that x through, just like we would normally solve these. And that's going to give you x squared plus 2x equals 63. We'll move our 63 over. And now we've got x squared plus 2x minus 63 equals 0. So these are going to have, again, multiple solutions. And we need to make sure that we find them all. So we're actually going to get 2 solutions and 2 sets of numbers. We can factor this pretty easily. First times the last is a minus 63. So remembering what we learned from 1-4, it's a minus 63, so what do we know about the signs? Are both numbers the same or are they different signs? Well, in this case, it's a minus 63, isn't it? So one's positive, one is negative, and the larger one is going to be positive. So where are we going to begin? Well, 63 is an odd number. So let's begin with some odd numbers. We can try 3. 3 is not going to work, right? Because 63 divided by 3, well, that's 21. Way too far apart. How about we try 7? 7 and 9. Does that work? Yep. So we need a positive 9 and a negative 7. There's no number in front, so we can jump directly to our factors. And so that's x plus 9. X minus 7 equals 0. Remember, we've done these before. And now we can get our solutions. So what do we have? We have x plus 9 equals 0. So x equals a negative 9. And we've got x minus 7 equals 0. So x equals 7. What are our solutions? Well, when we actually write these solutions out, we're going to get 2 sets. We have a positive set and we have a negative set. So let's start off with the positive set. So the first one is 7. And if the first number is 7, what's the next odd number? If the first number is 7, the next one when we add 2 would be what? 9. Now, why is that going to work? Well, 7 times 9 is what? 63. Right? They have to multiply together to give you what? 63. So 7 times 9 is 63, so that works. Now there's another set. What's the other set? Minus 9. And if I have minus 9 from here, and I add to that, I get a minus what? 7. Does that work? Yes, because when we multiply 2 negatives together, we get out a what? Positive. So these aren't that bad to solve. The consecutive integer ones are the easiest to set up, and they're going to be the easiest to actually solve. So we work them out, we get our 2 sets, and that's going to be what I want for the solutions. Both of them listed out with the pair that goes along with it. number 15 is the next one that we're going to look at. And it deals with sum of squares. So let's look now at question 15. Now, product was multiply, and this one we're going to be adding them together. So 15 says the sum of the squares of two consecutive odd integers is 202. Find the integers. So when we work these out, we're going to be adding them together and we're going to be squaring them. The first thing, though, we need to make sure we understand that these are odd. And if they're even or odd, what is my gap? 2. If it's just plain consecutive integers, it has a gap of 1. These are going to have a gap of 2. So the first thing we'll do is we'll figure out what we're working with, fill it in, and then solve the equation. This one's a little bit more challenging to solve, just because we're going to have to do a lot of foiling. So we need two consecutive odd integers. So that means my first number, again, is x. My second number, in this case, is x plus 2, isn't it? Okay. And what are we looking for? We are looking for the sum of the squares. So that means that we need the first number squared plus the second number squared equals now 202. Is everyone okay with that so far? Does everyone see where I got that from? So, what do we know? Odd integers, how many do we need? 2. Gap on these odd integers is a gap of 2. So the first one is always x, second one is x plus 2. Now, what are we doing? We are going to sum the squares. So that means we square each one and add them together. Now we fill them in. So the first number here is x. So that's going to be x, and we have to square it, so that's x squared. The second number is x plus 2, quantity squared, and it equals still 202. Is everyone okay with that so far? Now here's where it becomes a little bit trickier. When we work with this, we're going to have to FOIL. So let's work with this piece right here. And that's going to have to be FOILed out. So we'll go ahead and FOIL that out quickly. And so x plus 2 squared is x plus 2, x plus 2, and then we'll FOIL it. So we've got to FOIL it all out. So first times first, outside, inside, and last. So that's going to give me x squared plus 2x plus 2x plus 4. And that leaves me then with x squared plus 4x plus 4. Is everyone all right with that so far? So now we just rewrite it. We're going to combine like terms, and we'll solve this question out. So now when I rewrite it, we've got x squared. We've got x squared plus 4x plus 4, and that equals our 202. Okay, so that's our 202 there. Now, we can combine things together. So let's go ahead and combine those together. And that's going to give me a 2x squared, right, plus 4x plus 4 equals 202. We've got to set this to 0. So I'm going to subtract that 202 over. Now let's see what we've got. 4x there. And then we've got a minus. That's going to be 198, I believe. Minus 198, and that equals 0. How do we finish this? Well, when we go to work with this and we go to factor it, which we're going to be factoring, before we factor, we always check to see if we can divide a number out. It's going to make our life so much easier. And in this case, we can, because all of these have what in common? All of these have a 2 in common, right? So we want to divide everything by a 2. Rewrite and see what we're left with now. It's going to be much easier to factor when we do that. So now we have x squared. 4 divided by 2, that leaves you with a 2x. 198 divided by 2, that's a 99. And 0 divided by any number is still 0. We can factor this without much problem at all. First times the last is a negative 99. And we know 1 is positive, 1 is negative. Larger number again is positive. So what two numbers are going to work? Can someone tell me what two numbers multiply together to give me 99, subtract to give me 2? Yep, okay. 11 and 9. Now, how did I know that just by looking at this quickly in my mind that it was going to be 11? Well, whenever I see the digits are duplicated, like 88, 99, 77, it's going to have an 11 in it. So that makes it easier. So I already knew that 11 was going to be in there. This factors now into x plus 11, x minus 9 equals 0. So x plus 11 equals 0. So x equals a negative 11. X minus 9 equals 0. So make sure you switch your signs. And so x equals 9. Is everyone all right with that so far? Now, what are my two solutions going to be when I write them out? Well, when I write these out, I always like to do the positive first. So it's going to be 9, and the next odd number is going to be what? 11. So 9 and 11 is our first set. What about the second set? It's negative 11 and negative 9. How would you check? Well, you can easily check these because when I square them and I add them together, they should give you 202. So we can check that because when we take 9 squared plus 11 squared, it should equal 202. And it does because 9 squared is 81. 11 squared, I believe, is 121. And when I add them together, I end up with 202 equaling 202. So we know it checks out. Now, why does the negative work as well? Well, the negative is going to work because when we square a negative, it becomes what? Positive, right? So that's why we have two sets, and they work. We square them, add them together, and that gives us our 202. So pretty easy on the consecutive integer questions. When I made the homework up, I tried not to get into some of the really difficult questions. There are a lot of questions in this section that are very, very time-consuming and difficult to work out. So I try to avoid a lot of those. Some questions are easy to set up, but then the real challenge becomes working them out. So I tried to pick questions that weren't going to take you a real long time to work out. So that's the consecutive integer questions. The next type that we're going to look at is we're going to look now at some geometric figures. And we're going to look at question 21. And when we work with these, we need to make sure we understand the different figures and the special properties of those figures. What do we know about a square? Yeah, we're on page 148 here. What do we know about a square? What's special about a square versus a rectangle? On a square, all the sides are what? The same. So that's a very important fact that we're going to have to use here. So we're looking at question 21. We're going to look at the dimensions of a square. The length of each side of a square is 4 inches more than the lengths of each side of the smaller square. The sum of the areas of the squares is 149 inches. Find the lengths of the two squares. This is almost identical to what we just did a moment ago with the integers. So when we look at this, how many squares do we have? Okay, it looks like we've got 2 squares. And we've got the smaller square and the larger square. So we've got a larger square and we've got a smaller square. And what do we know about these? If we read it, it says the length of each side of a square is 3 inches more than the length of each side of the smaller square. So we don't know the smaller square. So that's unknown. That's going to be x. What do we know about the larger one? It says it's 3 what? 3 more. So what are we now going to do? Well, we want to find our areas. How do we find the area of a square? Area is length times the width. So let's do each one of these. What about the smaller square? Okay, length times the width. The smaller square would be x squared. What about the larger square? It would be x plus 3 quantity squared, right? These are areas. How do you find the area? Length times width. Not much to these. Now, what are we going to do? We are looking at these areas, and we are looking at the sum. And that sum is going to give you 149. So now we know we have the smaller area squared. Well, it's not squared. It's just the smaller area, because it's already squared, plus the larger area is equal to 149. And what do we know about the smaller one? Its area is x squared. The larger one is x plus 3 quantity squared. And that gives you 149. So it's basically the same as what we just did a moment ago. However, when we solve this, we are going to get 2 solutions, but we can't have a negative length or width. So one of them is going to get thrown out. So we'll need to make sure that when we look at these questions that we understand you might get multiple solutions, but only one of those solutions is actually going to work. In this case, sometimes you'll get 2 that work, like the consecutive integer problems, but this one we're only going to get 1 because if we have a negative answer, we have to throw it out. So what I'm going to do is I'm going to go ahead and FOIL, and we're going to work with this x plus 3 quantity squared. We're going to write it out. So we're going to write it out and we're going to FOIL. And if I FOIL this out, first times first is x squared, 3x, and another 3x, that makes it 6x, and 3 times 3 makes it 9. So that's what we've got so far. So all I did was I just wrote the grouping over to the side, and I squared it out. And now we can finish it. We're going to combine like terms. We're going to set this to 0. So go ahead and combine like terms, set it to 0. So move that 149 over. And combine those together, the x squareds. And let's see what we've got. So when I combine those together, I now get 2x squared I get a plus 6x, and it looks like a minus 140 equals 0. Okay. Always, always, before you go to factor, make sure you can't divide anything out. When I look at these numbers, these are all divisible by 2 again. So we're going to divide everything by 2 to make our life easier. If you don't divide by 2, you're going to have to do factor by grouping. But if you divide by 2, it's going to make it so much easier. So now when I divide by 2, I get x squared plus 3x, right? Minus 70. And that equals now what? That equals 0. We can factor it. First time's the last. Again, as a minus 70. Middle's positive. What two numbers are going to work to give me the 70 there? Okay, someone said it. We need a 10 and a what? 7, right? Because 10 times 7 is 70. 10 minus 7 is that 3 that matches up with the middle. So positive 10, negative 7. Factor that into x plus 10, x minus 7. Okay, and x plus 10 equals 0. So x equals a negative 10. X minus 7 equals 0. So x equals a positive 7. Now, what do we know? Why can we get rid of the negative 10? Why is that one not going to be a legitimate solution? It's not going to be a legitimate solution because we are looking at a geometric figure. Can you have a negative length or width on any figure? No. So this one is gone because it's negative, right? You can't have a negative length or width. So we can't have a negative length or width. So what's our answer going to be, and what do they want? Okay, it says find the lengths of the sides of the two squares. So when we draw them back up again, remember we had our two squares, and we had one that was an x, and the other one was x plus 3. So our value is x, so the first one, the smaller square, is 7. And what's the other one going to be? 7 plus 3 gives you then 10 inches. So our squares are 7 by 7 and 10 by 10. Those are the two squares. We can't have the negative because you can't have a negative length or width. But it's very, very similar to what we did with the consecutive integer questions. A little bit different is question 31. But it's actually a little bit easier, I think, to solve and work through, as long as we're careful with the wording. What is the length of a square if its area and its perimeter are numerically equal? So when I read this, first thing I look at is I notice that I have a square. That's my first key that I'm going to have to work with multiplying them together. So we've got a square. And we don't know the length and the width, but we do know it's a square, so they're going to be what? They're going to be the same. So let's now go ahead and find our area. An area of a square is the length times the width, which is x times x, and that is a x squared, right? And what about perimeter? Well, perimeter, no matter what the figure is, your perimeter is always the sum of all sides. Okay, so perimeter means we add up all the sides. That's the definition of the perimeter. So if I add up all the sides, that gives me then 4x. Is everyone okay with that so far? So we're looking at a square. We know the area is the length times the width, so that's easy enough. Perimeter, we just add up all the sides together, so that's why we have the 4x. Now, what is given in the question? We are given this. We are given the fact that the area is going to equal the perimeter. So that's given. So the area is going to equal the perimeter. Well, what do we know about the area? We found that to be what? X squared. And what about our perimeter? We found that to be 4x, didn't we? Now we should be able to set this to 0 and solve it. Now again, we may get two solutions, but there may only be one that actually works. So we're going to set this to 0, and in this case, we're going to factor. So move that 4x over. And now we've got x squared minus 4x equals 0. And what can I factor out of here? On the left-hand side, what's in common? Okay, so an x can come out. And that leaves you with an x minus 4. And that still equals 0. So pretty simple to factor. Again, when I made up your homework and when I work out these questions, I'm trying to pick ones that aren't really, really difficult to solve, because some of them are time-consuming on the solving. Not so much the setup, but it's just doing all the work behind it. So I try to pick things that factor easily, ones that you're not going to have to use the quadratic formula on, easier questions like that. So what are we going to get for our two possible solutions? Well, the first one, we factored an x out. So one solution is x equals 0. What about the other one? Well, the other one is x minus 4 equals 0. So x equals 4. Which one of these is not going to be a legitimate answer? 0. Okay, why is 0 not going to be an answer? Well, can you have a square with a length or width of 0? No. So 0 is not going to work for us. So that one's gone. So what's our answer going to be? 4. Now, there's no units. So our answer is just going to be x equals 4. We don't have any units of measure. So that's going to be your solution. The next type that we're going to look at is questions that involve using the Pythagorean theorem. And we're going to start with easier ones, because we're going to do 3 of these. And I'm going to pick out easier ones first, and then we'll look at the hardest one last. So we're going to talk now about the Pythagorean theorem and how the Pythagorean theorem works and what it is. So we're going to be using now the Pythagorean theorem. And the Pythagorean theorem, if we need a page number, this is on page 143. And this is the Pythagorean theorem. Pythagorean theorem, this works for a right triangle. When we talk about a right triangle, we have A, B, and C. And for a right triangle, we have A squared plus b squared equals c squared. And that's your Pythagorean theorem. And it's kind of like what we just did a moment ago with the areas, where we have to square each one, we add them together. So whenever we have a right triangle, we use the Pythagorean theorem. Carpenters use the right triangle a lot just to make sure when they build something like a door frame that it's square, because you use the 3, 4, 5 triangle to check and make sure that it's square. So it's used a lot in construction, and a squared plus b squared is going to give you c squared. Now, the only part that's important is we make sure that we know the diagonal part here is your c. That's called your hypotenuse. And we need to make sure that c goes on the end. The other two, the a and the b, they can go in either order. But make sure that diagonal is going to be your c squared there. So now let's work out an easier one. We're going to start with the easiest one first, and then we'll work our way to one of the more difficult ones. And I want to try to get through 3 of these. So we're going to start with the easiest one, and we're going to look at question number 38. Question 38. So we're going to be working with a right triangle. When we work these out, again, we may end up with 2 solutions, but only one of them may work, because you can't have a negative length or width. So what we're looking at is building the frame for a solar panel. So Yolanda has a solar panel with the width of 26 inches. So that's given there. To get the proper inclination for her climate, she needs a right triangular support frame that has one leg twice as long as the other. To the nearest tenth of an inch, what dimensions should this frame have? So we're going to get this to the nearest tenth of an inch. So when we draw our diagram here, and this is question 38, and it's on page 150. When we draw our diagram here, we're going to make a right triangular support frame. We know this solar panel is 26 inches in length. Now, we don't know either the length or the width of this support frame, but we know one is twice the other. So one is going to be called x, and the other is 2x. Doesn't matter which one is which, just label them. And that's what we've got. So we've got it labeled. We know it's a right triangle. Now, the only one that's very, very important is the C. We need to make sure that that C is going to be that diagonal. So when we work these out, you have to make sure that C is the diagonal. A and B don't matter. Just make sure that that C is the diagonal. And now we know from our Pythagorean theorem formula that a squared plus b squared is c squared. And so when you plug things in, a squared is an x squared. Now be careful with the b squared. Use parentheses because it's twice the length. So that's 2x. And we have to square it. So use parentheses there. And that equals 26 squared. Make sure when you work with that 2x that you put parentheses around it, because you've got to square each part, not just a 2x squared. It's actually going to be a 4x squared there, because that squared has to be distributed or pushed through each part. So when I do that, I now have x squared. 2 squared is a 4x squared, and that's going to equal 26 squared, which is a 676. Where do students make a mistake? It's right here. Because I know from past experience that what are students going to write down? 2x squared. It's not 2x squared. Make sure you use the parentheses, distribute through. It's 4x squared. Now, we've learned how to handle this from 1, 4. We're going to combine these together, and that's going to make it a 5x squared equals 676. We're going to divide by our 5. Because we're now going to use what property? Does anyone know? What property I would be using to solve this out? We would be using what? Square root property, right? Someone said it. Okay, so I want to get rid of a square. So how do I get rid of a square? I use the what? Square root. Now, what does it say? It says round. So we can go ahead and round here to the nearest tenth. So let's divide out and square. We're going to divide and square. Now, we have a plus or minus, but we only really need the positive case, because we can't have a negative length or width on this triangle. So let's use our calculator. We've got 676. We're going to divide that by 5. Okay, that gives you 135.2. Is everyone all right with that so far? And then we're going to take our square root. Now we're going to round to nearest tenth. And that comes out to then be 11.6 when we round. Is everyone okay with that so far? Does everyone see where I got that from? Let's go back and review. So I squared that out. That gave me the 4x squared. Now, what are we going to do? Well, we can't use zero factor, right? We're going to use our square root property because all we have is that x squared. So I combine them together. Remember, this is 1x squared here, right? So when I put them together, that gives me the 5x squared. I divide it. I left it as a fraction. Then how do you get rid of a square? You take the what? Square root, right? And you can do it all in your calculator, or you can write down the intermediate steps. So how did I work this out to get that 11.6? I took my 676. I divided it by 5. That gave me the 135.2. I took the square root of that, and that gave me then the 11.6. So we want the dimensions of this right triangular support frame. So we want to know the dimensions of the frame. So what are they going to look like? Well, one of them was x, and the other one was 2x. So this one is going to be 11.6 inches here. And what about the other one? 2 times your 11.6, and 2 times that 11.6, that comes out to be 23.2 inches there. Now let me show you another way to do this question with a different calculator, because everyone has a different calculator. A lot of you have this style of calculator, like this. So most of you probably have this type of calculator. How would I work out and get that 11.6 from this type of calculator? Well, what I would do is I would take that 676. I would hit my divide key down here. Okay, so 676, hit the divide key. Hit 5, and then hit equals. Okay, that gives you that. Now, I don't have to write it down. I can, but I need to take the square root. So how do I take the square root with this calculator? Well, I go under second, hit the second key, and see how it's in blue here, right? With the square root, we want that. Okay, and that's going to put that up there. Now, what do we type in? We either type in 135.2, or you can go second, answer down here, and that's going to keep your answer stored. And then hit your equal key, and that gives you the 11.6 again. So that way you don't have to write the number down every time. You can if you want to. And you can write it down, just type in the 135.2, or you can just use that second negative sign to get the answer. previous step story. But either way that you do it, you're going to end up with those two as solutions. Okay, let's look at another one here. Let's look at question number 40. So question 40. And this is very similar to one of the questions from your homework. Almost identical, just different numbers. This also is going to be a right triangle problem. And so on question 40, Tanner and Sheldon have purchased communication receivers. If they leave the same point in time, Tanner walking north at 2.5, Sheldon walking east at 3. Yeah, are we finished? All right, thank you very much. Okay, so one is walking north, one is walking east. Okay, and it says, how long will it be before... Yeah, I think you need a new homework packet here. And there we go. Yep, you're welcome. Okay, so we want to know how long it's going to be before they are 4 miles apart, right? Because that's the range of these communicators. So we're going to have to draw a right triangle. So let's draw our diagram here. We're on question 40. And this is again on page 150. And we've got Tanner walking north. So here's Tanner, and this is going to be the start. So Tanner's going to be walking north. And Tanner's rate is, where does it say it here? It says Tanner's walking north at 2.5 miles an hour. So his rate is 2.5. We don't know the time, so that's x. And we know Sheldon's leaving the same time, same point, and Sheldon is walking east. So that means Sheldon's going to be going east. So Sheldon's going to be going this way. And he's going to be going east here. And what do we know about Sheldon? Sheldon's rate of speed is 3, and his time is unknown, so it's x again. Now, how do we draw our triangle and finish it and label it out? Well, we're working with the distances. And remember, your rate times your time is going to be your distance. So when we draw these out, if we look at the distances here, and we did this way back in 1-2, when we did our distances, rate times time is your distance, so Tanner is going to be 2.5x, and Sheldon, going this way, is 3x, and how far apart do they need to be? It says in the question that they need to be 4 miles apart, so that's your total distance here. Is everyone okay with that? So that's how I set it up. Okay, 4 was given from the question, and hopefully I read it right here. It says, how long will they be able to talk to each other if the range of the communicators is 4 miles? So that means they can be up to 4 miles apart. And no matter how we look at it, the shortest distance between them is going to be a straight line. So this is always going to be your hypotenuse there. And that's your total distance, and that's your 4 miles. So now we can figure it out. We can work it out, because this is your A, this is your B, and this is your C. And we know that A squared plus B squared is C squared. And A squared is going to be 2.5 x quantity squared. B squared is 3x squared there. and that equals 4 squared. So we plug those components in. And make sure you put parentheses because you have to square the numbers as well, the coefficients in front. So you've got to make sure that you square that 2.5. Okay, so let's do the 2.5. 2.5, we're going to square that. So that's 6.25 x squared here. 3 squared is 9x squared. 4 squared is 16. Now we can finish it. We're going to solve it just like we did the last one with the square root property. So we're going to add them together, and then we're going to take our square root. So adding these together, that gives you 15.25 x squared equals your 16. We're going to divide by your 15.25. I'll use the other calculator here just so we know. This is what most of you have for a calculator or something similar to this. So I'll work it out with this one. Okay, that gives you x squared now equals 16 over 15.25. You're going to take your square root, right, plus or minus. How do I do it again in the calculator? So we take our 16, divide that by the 15.25. That gives you that. You don't have to write it down because you have at the bottom that answer key in blue. Remember, it's in blue. So how do we get to that? We take our second square root, which is here, second square. Second, hit the second key. Answer down here, that stores your answer. And now we're going to hit equals. And that gives us now, and we'll take this out probably 3 places because this is in hours and we want it in minutes. So when I work this out, that gives you, now we'll write it down in hours, 1.02, if we round it 4, it looks like, hours. But we want it in terms of minutes. So we want minutes. So we want minutes here. How do we convert this hours to minutes? Well, we take our 1.024 and we're going to multiply it by 60 because there's 60 minutes in an hour. And how many minutes should it take for them to be that 4 miles apart? Well, if we work it out and round it, 1.024, we're going to multiply that by your 60. And that is then 61.44, or about 61 minutes. Let me write it out right. So that's going to be your answer there, 61 minutes. So it should be about 61 minutes that they can continue to talk for. So you got 2 people, they're traveling, one going north, one's going south, one's going north, one's going, in this case, east, makes a triangle. We solved it out. Now, we didn't need the negative because you can't have a negative time. It is there, but we don't need to use it because you can't have a negative time. What we found was in terms of hours. We then had to convert the hours to the minutes because it wants your answer in terms of minutes. I don't think we have enough time for another one of these, but we do want to look at some questions that involve gravity. So we're going to look at a couple of these that involve gravity. And what do we know about gravity? Well, when we throw something up in the air, right, it goes up for a bit and then it does what? It comes back down. So when we look at these that involve gravity and you throw something up in the air or rocket goes up in the air, there are 3 different outcomes. So when we look at questions that involve gravity, you've got three different outcomes. When you throw something up in the air, what forces it to come back down? Gravity does, right? Okay, so there are three different possible choices when it comes to your answer. So if I have a rocket and I launch this rocket up in the air and it comes back down, and this is going to be your height over here, okay, and this is time, and this is your height. Let's say I want a height of, in this case, 50. Okay, if I say a height of 50, look at how many times this crosses the curve. It crosses twice, right? Once there and once there. So you're going to have two solutions. Because you've got one going up and you've got one coming back down. So you can have two solutions. Okay, one going up and another one on the return trip coming back down. You can also have one solution. How can you get one solution? Well, if I redraw the rocket ship again, and this rocket ship goes up and it comes back down. But let's say in this case, I want 90. 90 would only touch this at one place, so this would give you one solution. Because that's going to give you the highest point, so you can have two solutions, or you can have one solution, or you can have no solution. How can you have no solution? Well, no solution would be, again, similar figure. It's going to go up, and it's going to come back down. But this one would have no solution, because let's say I want this value up here. Let's say I want 150. Well, 150 never crosses, so this one has no solution. So when we work these questions that involve gravity out, you can have two solutions, one up, one on the return trip coming back down. You can have one solution if you ask for the highest point, or you can ask for something that can't happen and you would have no solution. So when we talk about gravity, there can be three different scenarios. Two solutions, one solution, no solution. So to work these out, think about what you got, and it'll make sense as to what you get. Now, how can you have no solution? Well, no solution would be a complex number. If you solve out these equations, and you get a complex number, an imaginary part, no solution, because we cannot have an imaginary answer. So this would be imaginary numbers. If you get imaginary numbers, no solution. These are real. So let's try to work out at least one of these. And let's look at question 47. And we're going to do part A, and we're going to do part B. So we'll try to do them both. I think we have enough time to do both of these. These are going to require us to use the quadratic formula. Question 47. So t squared plus 30t plus 6.5. So here's our equation. And you can read through it, but what we're mainly concerned about is the equation and what the pieces represent. Now, why is it negative here at the beginning? Okay, well this minus 2.7, that's going to be your effects of gravity. It's either minus 2.7 or it's 9.8. Because 2.7 is feet per second. 9.8 is meters per second. So it's either going to be one or the other. They'll give you these equations. And you just plug the numbers in. The 30, that's your starting speed, your starting power behind the rocket. And that 6.5, well, that's how tall you are, where you start at. S represents the starting height. Or not starting height, sorry, ending height. Let me write it down correctly here. So the ending height. Okay, so that's where you end at. So this is our equation, and that S is going to represent the ending height. And that's the only part that we have to plug the numbers into. All the rest of it is taken care of. And for part A, we want to know how many seconds the ball is 12 feet above the moon's surface. So that 2.7, that represents the gravity on the moon. It's different on Earth, but in this case on the moon. That's that 2.7. On Earth it would be different. It would be 9.8. Okay, so we're looking at how long it takes this ball to be 12 feet above the moon's surface. Well, if we want to know how long it takes it to get 12 feet above the Earth's surface, what's my ending height? Where do we want to end at? Okay, I want to end 12 feet above the surface. What is that going to look like? If I'm throwing a ball, in this case we're throwing the ball up in the air, and it's got to come back down. That's what we're doing on this question. Okay, we're throwing the ball up in the air, and it's coming back down. And I want to find the time it takes for this to reach a height of 12. Now, if I wanted to reach a height of 12, how many solutions from the picture should I have? 2, right? One on the way up, one on the way back down. This one says use the quadratic formula because it says round. Anytime it says round, we're going to have to use the quadratic formula. And it says round to the nearest hundredth. So let's plug in our values. So what's my equation going to look like? Well, it's going to look like 12, because that's your S. So 12 equals a minus 2.7 t squared plus 30t plus 6.5, because that's your S, right? We just plugged in. That 12 was the S. That's the only part we have to plug in. Whatever value they give you, you plug it in. We're going to move that 12 over. And we're going to set this to 0 so we can deal with it. Okay, so we'll move that over. Okay, and that gives you that minus 5.5. Is everyone okay with what I did there? Just plug my values in. That's all I did. Okay, set it to 0. Now, do we ever want to start the quadratic formula with a negative value? No. So to make it easier, get rid of the negative. So just distribute a negative through. That way it stays positive. So switch your signs out. It's just going to be easier if it's positive for the quadratic formula. So switching those signs, we get this. When we go to solve this, we can either use the decimals or we can get rid of them. I think it's easier to just use the decimals. So we're just going to go ahead, in this case, and use the decimals. So you can use the decimals in the quadratic formula. You can get rid of them by multiplying by 10. But I think that makes it more difficult. We have calculators. We can use a calculator here. Okay, so we can go ahead and use our calculator, and we're going to plug in our A, B, and our C. We're going to apply our quadratic formula. We've got it all listed out, so let's find our components. A is 2.7, B is a negative 30, C is 5.5. Apply your quadratic formula. Write it down again if you need to. We've used it quite a bit. Plug your values in. You should see that's a 2.7 there and 5.5 there. And that's all going to be over 2 times a 2.7. And we're just going to use our calculator. So let's do like we normally would. Let's clean this up a bit. We know that the double negatives here are going to make that positive. So that makes that 30 plus or minus. And we need a 2.7 times 2. That's 5.4 there. We'll work out our discriminant over here. Okay, now our discriminant is everything that's underneath that square root. And 30 squared, well, that's going to be 900, I believe. Because when you square negative, it becomes positive. A single negative stays negative. We've got 4 times 2.7 times that 5.5. When we use our calculator here, right, we're just multiplying those out for this part. We know it's going to be negative. And that is 59.4. 900 now. Minus that 59.4, that leaves you with 840.6. Okay, is everyone okay with that so far? It's just using our calculator. We just use the decimals. Now, what does it say? It says we want our answer to the nearest hundredth. Hundredth is 2 places, right? Because you've got 10 which is 1, 100 which is 2, thousands which would be 3. Let's go ahead and take it out to 3 places for the square root, round to 2 for our final answer. So go ahead and take this square root here out to 2 places. So let's go ahead and just take our square root here. So that's going to be the square root of 840.6. We want this out to 3 places. And then we'll get our 2 solutions. So that's going to be 30 plus or minus 28.993 over 5.4. And what does that give you? Well, we're going to have 2 solutions. Let's write them out. So we have 30 plus 28.993 over 5.4, so there's 1. What's the other one going to be? 30 minus 28.993 over 5.4. Add and divide here. Okay, so that's going to come out on the top here to be 58.993 over 5.4. We're going to round to 2 places, so we'll divide that out. And now we round at the end, and that rounds out to 10 point, if we round 92 seconds. So there's 1 time. Okay, so there's one of them. What about the other one? Okay, well, it's 30 minus 28.993. That comes out to be 1.007. Divide that by 5.4, and that comes out to be our other one, which when we round is 0.19 seconds. Okay, we got two solutions, didn't we? Right? Why? Because you got it when it goes up, which is this 0.19 seconds. And then 10 seconds or almost 11 seconds later, you get the second one. Now, we need to do part B, but part B is the easier part. Part B is we're going to return to the ground. So we're almost finished here. This is going to be our last question, by the way. So we'll finish this one. And that will finish out the lecture for today. So we're going to look at part B. And part B says we want to return to the ground. Hit the moon surface, return to the ground. So we're going to go ahead and return to the ground here. Now, when we return to the ground, that means S is going to be 0. Right? Because we want to return to the ground here. So S is going to be 0. So that's a minus 2.7 t squared. And then again, same question again. We're just going to plug in our values. Plus 30t plus 6.5. And that's going to equal 0. A little bit easier to solve, a little bit quicker because it's 0. So one less step. We never want to begin with a negative, so we've got to divide by or multiply by a negative here because it begins with a negative. So just do a multiplication, distribute it through again. So that is now 2.7 t squared minus 30t minus that 6.5 equals 0. Right? So we did that. We distributed it through, changed our signs because we have to divide by a negative, multiply by a negative, either one, same thing. Our A is going to be 2.7. Our B is going to be a minus 30. And our C is a minus 6.5. And we should have just enough time to finish this one. Use our quadratic formula again. X equals minus B plus or minus the square root b squared minus 4ac all over your 2a. And plugging our values in, we have a minus of a minus 30 plus or minus square root of a minus 30 squared minus 4 times a, which is 2.7, times c, which is a minus 6.5. And that's all over 2 times 2.7 again. Now, in this case, we're only going to get one solution. We're going to get 2, but we can't have a negative answer because we're looking at time. So let's quickly finish this one out. We should have just enough time to finish it here. Double negative makes that positive. So now when we do that, we have a 30 plus or minus 2 times that 2.7, that's a 5.4. We work our discriminant over to the side. And we have a negative 30 squared minus 4 times 2.7 times a minus 6.5, so that's 900. Double negative makes that positive. And that gives you a 70.2. So that's 970.2. I know I'm going through it pretty quickly, but we're almost finished here. Okay, let's try to keep that side noise down just a little bit so we can finish here. I don't care if you kind of whisper to each other if you have questions, but I try to keep that down a little bit. So we got to this point. Okay, let's go ahead and break it up and see what we get. So now we have 30 plus or minus the square root of that 970.2 That's going to come out to be this, right? Square root of that 970. That's going to be 31.148 if we round. Over 5.4. We're going to get two solutions, but only one of them is going to make sense. So we've got 30 plus 31.148 over 5.4. And the other one is 30 minus 31.148 over your 5.4. Why can we get rid of this one here? Well, if we think about it, what are we working on? We're working with time, right? Can time be negative? No. What happens when we take 30 minus 31? That comes out to be what? Negative. So we don't even have to work this one out. It's negative, so we can't have a negative time, right? It's gone. And that's how you get the one solution. Let's go ahead and finish up the numerator. We add these together, and we get 30 plus that 31.148. That comes out to be 61.148 over that 5.4. And now we divide, and we round to 2 decimal places. And that rounds out to be 11.32, and that's seconds. So it's going to take 11.32 seconds for that ball to return to the ground. So what's our homework? Well, our homework is 1.5. So that's going to be our homework for next class period is 1.5. And we'll have some time next class period to work through these. We have questions out of the homework. So try to work through 1.5. I tried to pick easier questions to set up and ones that weren't as difficult to actually solve. So next, on Thursday, we're going to go over these questions. So Thursday we'll be going over these questions and looking at 1.6. So I will see everyone then on Thursday.